Afternoon, everybody. Larson here. We are going to go over the quiz that you took last Friday because I think sometimes when you see the problem worked out, you can get past the kind of freak out factor like, oh my goodness, I don't know how to do that. So I'm just going to work through the problems and demonstrate how I think you should, what technique you should use. And you'll notice that I'm using a particular one. A lot of you aren't showing much work. And what I'm suggesting is I can help you better if you show your work because I can see where kind of mistakes happen. And then I can not only help you, but I can help others in saying, hey, a real common mistake is here. So we're going to just start by looking at question 1. And I'm given this equation and I'm asked to solve for y. And so, given this equation, this is what I'm asked to do. I need to solve for y. So, here we go. We need to get this to the other side. That needs to be removed, and we do that by when it's plus 7x, the opposite of that action is subtracting. So I'm going to subtract 7x. This is 0. That's good news. It goes away. And so all I'm left with is 5y and this 30 minus 7x. And then the next step is, I notice this is 5 times y. There are 5 y's there. And I need to only have one y. So the way I do it is I think to myself opposite, inverse. I always do the opposite. So I divide by 5. And what ends up happening is y equals this thing over on the right. And so what I would suggest to you is that we're going to divide this fraction up into two different fractions. We're going to write 30 over that common denominator of 5 minus 7x over 5. And then what we're going to do is simplify, put it in the simplest terms we can. So y equals 30 over 5 is just 6, and then 7x over 5. Okay, so what you notice is the correct answer would have been A. Right away, I just want to do a little test-taking strategy with you. One of the things I've enabled on the quizzes and tests is something called elimination. And if you're solving for y, what I hope you saw right away is this is x equals. Right away, you should have said, no way, I'm not doing that one. That can't be it. The other one that you could eliminate right away is 5y equals 7x. We wanted to solve for y. So right away, by just eliminating answers that don't make sense, you got 2 to choose from. You really shouldn't guess, so you have to go through this work, and that's what I would have expected to see on a piece of paper in terms of showing your work. So just wanted to give you that strategy, especially as you come up to something like the ACT, SAT, or MCA, because just eliminating answers that don't make sense can be really helpful and time-saving. So in this next one, we're going to use that same equation that we had, and what we're asked to do is find the value of y, when x equals 10. So wherever I see an x in this equation, I'm going to put a 10. I substitute in 10 and leave it and then go, okay, what can I do? What do I know? Well, I know 7 times 10 is 70. That's good. What else do I know? I know I need to get y by itself. Get it by itself, so y equals, that is the value of y. So I know if I add 70 here, the way to get it to the other side is subtract 70. Then I end up with 5y equaling 30 minus 70 is a negative 40. And what I need to do with that then is 5 times y, the opposite of multiplying is dividing, so that goes away, and I have to do it to the other side. So I end up with y equaling whatever the value of negative 40 over 5 is, and I hope right away you go, oh, Larson, that is negative 8. So the answer was that one. Moving on to the next series of questions. And you notice they kind of come in a pair where we do two things. We solve for something, and then we evaluate or find the given value. So in this one, again, what I'm given, I wrote down, and what I'm trying to solve is y. And so right away, I go, okay, I got to get, this is the only y that I see, so I'm going to try to get it by itself. I want to eliminate this and eliminate that. And then what I want you to be asking you is, what do I know? What do I know? I know that to get rid of something, to bring it to the other side, I have to have 0 on one side and I move it to the other. So what would it take right here to make this 0? And hopefully you're saying, well, subtract it, Mr. Larson, subtract it. You're right. If I subtract 3x there, I need to subtract 3x on the other side. Because when I do that, this goes away, and what I end up with over here is 5x minus 3x, that is 2x. And then I also, kind of in this same idea, go, okay, I got to get this by itself, so this has to go. This 9 has to go. It's plus 9 to get rid of it. I subtract 9. That is 0. That's good news. So I'm ending up with a negative 2y on the left, and then this 2x right here that I wrote down before, and 21 minus 9 is a positive 12. So what that means then is I need to get rid of this coefficient in front of the y, get rid of the negative 2. So I divide by negative 2, and I'm going to divide the whole expression on the right by negative 2. Good news again, that cancels. I'm left with y. And then I'm going to break this into kind of from a complex fraction into something that's individual and less complex and easy to simplify. And so I have this part of the numerator, 2x. I'm going to put it over this common denominator of negative 2. Then I'm going to add this part of the numerator and divide it by the common denominator. Because by doing that, then I can simplify a little bit more. You'll notice this right here, 2 over negative 2, that is negative 1. So I can just write negative x. And then I notice here, I know how to divide negative 2 into 12. You know, my answer is negative, and 12 divided by 2 is just 6. So here's the solution for what y is equal to. I've solved for y, and so that would be that response right there. Now in this one, there aren't a lot of things to eliminate right away, but I can tell you that hopefully you looked at this and go, that doesn't make sense. I'm getting rid of that one. And really, this one up here, that is a typo, because typically in an equation, we don't have 2 equal sign, so that's got to be wrong. So right away, I've eliminated 2 of the 5 possibilities just by kind of trying to use some common sense. So that's question 3. The same equation, but this time I'm going to find the value of y when x equals 1. So I'm coming up with a number this time. So let's just write down what we start with. And wherever I see an x, I'm going to put in a 1. 3 times 1 minus 2y plus 9 equals 5 times 1 plus 21. Well, I know that 3 times 1 is just 3. And 5 times 1 is just 5. So what that allows me to do is simplify. Now I'm going to put common terms or like terms together. The 3 doesn't go with the minus 2y, but it does go with the plus 9. So 3 plus 9 is 12. And 5 plus 21 is 26. So it comes down to this. I need to get the y all by itself. How do you get rid of this 12? Hopefully you said, well, Lars, you subtract 12. You're right. This is 0. 0 minus 2y is a negative 2y. 26 minus 12 is 14. So to wrap it up, we go, okay, negative 2 times y equals 14. I don't like that negative 2. Get rid of it. What do? What do I know? Opposites. Negative 2 divide by negative 2. This cancels. I'm left with y equals, and 14 divided by negative 2 is a negative 7. So are there any here that we can eliminate right away? Not really. There's nothing that's kind of a duh that can't be. I mean, all of them could be possibilities, but I think if you put them in there and checked, the only one that makes any sense is what we found down here, y equals negative 7. So there really isn't a good technique of trying to eliminate any answers on that one. Okay, moving on to a very relevant equation in all of our lives, because we're constantly hearing about what the forecast is for the next day. And usually in our part of the world, we are given it in degrees Fahrenheit. But in most of the world, they use degrees Celsius. So many of you talked about wanting to travel, and so when we did things about the bucket list and other Flipgrid things, you talked about loving to go places and wanting to go places like Bora Bora. And anyway, in most places in the world, besides the United States, they use the metric system, and part of the metric system is measuring temperature in degrees Celsius. And so what we really want to do in this one is we just want to take this formula or this equation, and we want to solve for this so that we can bring some meaning to a measurement of Celsius. So we start out saying, okay, C equals 5/9 times F minus 32. And what I'd like you to recognize is this is 5/9 times this quantity of F minus 32. So it's as if I have 5x equals 15. And if you had a problem that simple, you'd say, Lars, all you do is you divide by 5. 5 times this 5x times this quantity, the opposite of it is dividing by it. Well, in the same way, I'd like you to think of this as just a number. And if I have that number times a quantity, how do you get rid of it to bring it to the other side? You divide by 5/9. And if you do it to one side, people, you're obligated to doing it to both sides. So what we notice is this cancels out, and this is really kind of beautiful because then I'm left with this on the right side, and I'm left with this C over 5/9 on the other side. And hopefully you agree with me that you know that when you have something over something else, it really is just a division problem. And the reason I write it like that is because most of you would also remember that when you divide by a fraction, we flip it over and multiply. So this is really C times 9/5 equals, and I'm just going to drop the parentheses there and just have F minus 32. So I have C times 9/5 equals F minus 32. And then I say, okay, I'm solving for F. I don't want the 32 there. Get rid of it. It's subtracting 32, so to get rid of it on that side, I have to add 32. And so to bring it home, I'm going to just write the number in front of the variable and say 9/5 C, and then you notice I have plus 32 here equals F. And what you would notice is that this is the correct answer, and everything else is just kind of sort of a variation of that. And there really isn't anything that you can eliminate that's an obvious. You really have to work it out to find out that, yes, that's the way to convert degrees Celsius, plug it in here, and get the temp in degrees Fahrenheit. Okay, so what we would want to do then, a real quick way, is remember what this equation is, that F equals 9/5 c plus 32. You just solve for that. And what we want to do in this next one is the formula to convert Fahrenheit to Celsius is that. What is the temperature in degrees Fahrenheit when it's 50 degrees Celsius? So what that means is wherever I see a C, I'm going to put in a 50 degrees. So F equals 9/5 C plus 32. And what I didn't do is put in 50 for the C. And so then to kind of work this out, remember anything can be written as a fraction if you put it over 1. So 9 times 50, I'm just taking top times top, is 450. Bottom times bottom is 5. That is equal to degrees Fahrenheit. 450 divided by 5 is 90 plus 32. And finally, we say, well, that means the degrees Fahrenheit is 122. That would mean it's pretty hot out. That's got to be the temperature maybe down in Phoenix, down in Death Valley, different places, Palm Springs in the summer. 122 is really blistering. We have never had that, I don't think, that hot in our part of the country. Okay, getting down to the very end. This was the most challenging problem, and I'd like you to pay close attention on what we want to do. We want to solve for z, and we're given this equation. And so to solve for z means I've got to get them all on one side and everything without a z on the other. So I'm just going to go, okay, I don't know exactly what to do, but I know that this really should go over there with the other z, and this should come over here with the y, so that I just have all the z's isolated, either on the left or right. So you see what I'm suggesting that we do is we subtract this. So next and by the way, the other thing we can do is, in order to move this over here, this is a positive 1, so I'd have to subtract 1 and subtract 1. So that what you end up with is this goes away, that's gone. And what I end up with over here is the y and a minus 1 equals, remember this went away, and I'm left with a negative y z minus z. And so the next thing we want to do is go, okay, I need to get rid of something. I have to get z all by itself. And so here is the kind of trick that you might have to remember from a previous math class. That sometimes you have to go, okay, there are two z's here. I can't combine them because they're not like terms. Is there a way that I could pull that z out front and then isolate it by itself? And so what I'm asking myself is, what times z is equal to this term right here? In other words, what I'm doing is I'm factoring. I'm pulling something out to make it simpler. And if you have asked yourself the question, what do I multiply z by to get this term right here? Hopefully, in time you will say, well, negative y. You're right. And then, so we're set. This times negative y is this term here. Now, what times z is this minus z over here? Well, hopefully you said, well, clearly it's a negative 1. And so, that sounds good. I'm going to close that parenthesis, and what I always kind of check for is z times negative y equals this, z times minus 1 equals that. I've done it correctly. Okay, so, the next thing I want to do is try to get rid of something. And I want, this is z times this quantity, And if I divide by this quantity here, on that side, to cancel it out, I have to do it over here as well. And I'm almost done because I have z equaling this. But what I notice is there's nothing up here that is exactly like, I mean, these two are close, but there's nothing like what I have here that looks like that. So what I'm going to do is say, okay, is there anything else in here that I could take out? Take out and factor out a number. In fact, the thing I don't like, sometimes I ask myself that question, what do I don't like? What don't I like about this? And it's that there are two negatives there. So, well, what would happen if I said, what times -1 is this negative y? Hopefully you'd say y. And what times -1 is -1? And you'd say, well, it's +1. So what I'm suggesting is I'm going to factor out a -1 out of that denominator and leave the numerator the same. So right away, I go, okay, this is looking better. I have more possibilities. I know it can't be just z 1/2, and I know all of that stuff doesn't really cancel out there, but the other stuff are possibilities. So how can we get this? Well, what I'd suggest is, if this is 1 over -1, does it make any difference if I have that or this? Hopefully you say, no, it doesn't make any difference. -1 over 1 is the same thing as 1 over -1. So what I'm going to do is then multiply this in here, and here I'm going to distribute it because it's kind of a messy thing to leave that way. And so I have -y plus 1 all over 1 times this 1 plus y, y plus 1, sorry, and that equals z. And so then finally you go, okay, typically we don't write it -y plus 1. We write it as 1 minus y over 1 plus y equals z. And if you look up here, that is the answer right here in G. That was a really complicated problem. And the reason it was complicated is we wanted you to be able to do the reverse of multiplying, and that is factoring, or the reverse of the distributive property is called factoring. So that was one of the problems, that if you got that, you have a really solid handle on solving equations and evaluating expressions, and really you're way ahead. So then finally, to wrap this up, to make myself some more room here, let's look at this problem. We're going to take this same one that we were working on, and all we're going to do is we're going to find the value of z if y equals 2/3. Okay? And what I'd suggest is, if you solved the problem and got this is the answer, that's the easiest way to deal with it. That z equals 1 minus y over 1 plus y. If you plug in 2/3 into this, that's the easiest way to find out z. But maybe let's say you didn't think that because you didn't get that problem. You didn't think of doing that. So instead, let's just take z plus y equals 1 minus yz. Let's say you know that when you are finding the value, you're supposed to plug in wherever you see a y, you put in 2/3. So z plus 2/3 equals 1 minus 2/3 times z. And so what we end up with is this step. So I have to get the z's by themselves. So right away, I go, okay, then I'm going to have to bring this over here. And this is 2/3 z, minus 2/3 z. To get rid of it, I have to add it. I always do the opposite. So right away, those go, and I have 1z plus 2/3 z is 1 2/3 z. Then I go, okay, I got to get rid of that 2/3. It's an adding 2/3, so just get rid of it, I have to subtract. And what I end up with is 1 minus 2/3 is just 1/3. And over here, it isn't always good to use a mixed numeral. It's a whole number and a fraction. That's called a mixed numeral. So let's change it. 1 times 3 is 3, plus 2 is 5/3 z equals 1/3. So in order to finish this off, this is 5/3 times z, so I have to divide by 5/3. If I do that on the left, I also do it on the right. This cancels, and I end up with z equaling 1/3. It's divided by 5/3. And what that means is that it's the same as 1/3 times 3/5. That's what z equals. And so what I end up doing is I go top times top. That is 3. 3 times 5 is 15, and then I reduce. 3/15 is the same as 1/5. So going back here, it looks like that is the correct problem. And there weren't really too many that I could eliminate just kind of by common sense. So thank you for listening. What we've been doing, our learning target today is just trying to learn from getting anything wrong. And making sure that you show your work completely, because the 9th question was, of course, upload it so that I can see your work. And many of you did, some of you didn't. Make sure that you do that, because it's just a real easy point to earn on any formative or summative quiz or test.